Question 13 is your integration by substitution question. I'm going to do u equals x plus 2. Some other people might want to do a slightly different substitution of the square root of x plus 2. I think this way is a bit easier. This way we mean that du and dx are both the same. We're also going to need later on that u take away 2 is equal to x, so I'll do that here as well. I also need to change the bounds so that when x is equal to 0, u is equal to 2, and when x is equal to 2, u is equal to 4. Let's put that in. So I'm trying to do the integral, not between 0 and 2 anymore, but between 2 and 4, of 2x times by, this is the square root of u, dx is simply du. That doesn't look too bad. Don't like this x here though, so let's get rid of that. So I've got the integral between 2 and 4 with 2 lots of u minus 2, and rather than writing u square rooted, I'm going to write u to the half du. And we've got our mark. Our mark there because everything's in terms of u. Let's multiply this out before we integrate it then here. So I've got 2 and u times u to the half. So I've got u to the 3 over 2 there. I've also got minus 2 times 2 is 4 here, u to the power of a half du. This is the integral that I need to do. The power goes up by 1. We divide by the new power. There was already a 2 there, so 2 times by 2 over 5 is 4/5 there. Here I've got u to the 3 over 2, and 4 times 2 makes 8 over 3. There's that bit there. We've now integrated. Integrating, we need to put in the values of 2 and 4. I'd love to be able to just tap this in the calculator, but unfortunately, because of this root 2 here, it gives a decimal answer. And so we are going to have to actually continue with this. I think I'll go up here, as we've still got some room. So I'm just going to put this one in as just putting in the number in. So I've got 4/5 of 4 to the 5 over 2 minus 8/3 of 4 to the 3 over 2. We're going to work that one out. And then we're going to take away 4/5 of 2 to the 5 over 2 and 8/3 of 2 to the 3 over 2. And we're going to work those ones out. Again, it's really no calculator. I mean, to be honest, this one you could do on the calculator, but let's show you how you don't. So I'm doing 4 here square rooted. 4 square rooted is 2. Then I've got to do 2 to the power of 5. That's 2, 4, 8, 16, 32. And then I've got 32 times by 4 divided by 5. 32 times by 4 divided by 5 there. This one here, I've got 4 square rooted is 2. 2 cubed makes 8. 8 times 8 is 64. I've got 64 over 3 there. There's the first bit. Now I'm going to work out the second bit. Now this unfortunately has got a root 2 in it. So the square root of 2 is root 2, but we've got 5 of them. So look, that's 2, that's 2. So the grand total of this bit here is 4 root 2's. 4 times 4 is 16. I've got 16 over 5 root 2's here. Same thinking here, I've just got 3 of them there. So this bit here is 2 root 2 times by the 8. I've got 16 root 2's over 3 there. And we're taking them away. Well, I'm just bringing up the calculator here. I think I'll do this bit now. I mean, you could now, as you've done so far, why not just change it all to 15ths? But just working out that bit. That gives me 64 over 15. And this bit here, we can see there's a root 2 there. So just ignoring the root 2, if you're sort of struggling with this, I've got 16 over 5, take away 16 over 3. 16 over 5, 16 over 3. So it's take away, it's a minus. I've got minus, minus. I've got 32 over 15 now. Well, look at that. I've got 32 over 15 here. So there's just a root 2 there. And notice, look, that's just 2 of them. So I've got 32 over 15, 2 plus root 2, as we were asked to show. I think just going back, look, This thing here really could have been done on the calculator. You would have got straight down to there. This bit here really couldn't, and so you needed to think about that. What you might have been able to do is just actually see that this is root 2 to the power of 5. But there's the final answer. Hope you got that.